We've now fitted both cylinders. We now have to install the flat washer and nuts, 4 on each cylinder, to hold the cylinder down. They are down in the depths of the inner section of the cylinder. Just install the washer on a screwdriver, locate the screwdriver on the top of the stud, let it slide down and just work it around. The nut generally has to be retained in the end of the socket. If we get a little bit of grease, just putting a small amount in the end of the socket or on the top of the nut, that will help retain the nut as we start it down over the stud. Installing our washers first. Then our nut. We just lightly put all the 8 nuts on there. We've now installed all the washers and nuts, holding the cylinders down. Prior to tightening them right up with the correct torque, we just install our cylinder flange aligning tool. This is to ensure that our exhaust flange faces are in line, and when the exhaust manifold is put on there, that it is not going to distort the cylinders or cause excessive loading to the exhaust flange. Not excessively tightened, just nipped up enough to pull them into alignment. Setting our torque wrench to 18 to 22 Newton meters. We'll now torque the nuts. There is a set sequence on the cylinder head tightening and the cylinder tightening pattern. These are listed and shown in the repair manual. Tighten all the bolts up until the specified torque. Then we'll proceed with fitting the cylinder head. We've now tensioned down the cylinders. We're removing our aligning tool. These particular water-cooled engines have neoprene or Buna type O-rings around the actual cylinder sleeve area and around the outside water jacket area. We always install new O-rings regardless of how many hours the engine may have done at the time of head removal. These sealing rubbers are installed dry. There is no silicone type lubricant or adhesive utilised. After installing the sealing rings and prior to fitting the cylinder head, we just do a final check that our combustion chamber areas are clear, that our pistons are in fact installed in the correct manner, and then we can go ahead with fitting the cylinder head. The cylinder head will only fit one way. It goes on dry. There is no adhesives or sealants put on. There are variations of nuts, spaces between various engines, so if you haven't just pulled down your own particular engine, you've just received it pulled down in a box or whatever, please ensure by the correct parts manual that you are installing the actual parts for that particular engine. The cylinder head is torqued in a cross sequence. of which we torque up gently until we reach 22 Newton meters. The sequence is called up in the book. We're now up to installing the rotary valve disc and housing. We need to install our dial indicator into the top of the magneto side piston. We'll be rotating the engine counterclockwise until we have top dead centre on the PTO piston. We align our dial on the 0. So we now have top dead centre. We can wind it back. We fit our rotary valve disc, which we'd previously marked. Turning the crankshaft again counterclockwise from the PTO end so that we have the take up of the gears onto the shaft, and this will then be onto the disc. We'll rotate around to our top dead centre and we check our previous mark to see that we're in alignment. In this case we are. If we were changing the shaft or putting a new disc on, we would be doing exactly the same. However, if we were finding that it was out, we'd be removing the disc, moving it around onto another tooth and then retrying. So we've ascertained that we are correct there. We would just put a little bit of lubricating oil around, bit on the housing. We have our carburettor mounting and rotary valve cover. We'd be putting a new sealing O-ring. We're now mounting the cover. It will only go one way. The holes are offset. At this point we can only put the bottom 2 mounting bolts in because there is other accessories that will go on there or need to be located on there later. We just firmly hold the cover, wind in the bolts, and then we will just nip them up with the socket and the wrench, and final tension will be completed after we mount the other accessories. Remove the dial indicator. We'll proceed to the next assembly point. We're now moving on to installation of the water pump seals. The drillway that we just indicated is a leakage bore area in case the outer water pump seal leaks. To stop it gravitating through inside to the rotary valve area, the drilling is provided to allow that water to flow out, be observed, and then obviously you would be looking to correct it by fitting a new seal. There has been over the years a few modifications to this area. The one we are doing at the moment is the current correction. We have 2 seals which when installed will actually be back to back. We are looking to preserve a silicone grease area within the seals and also between the 2 seals. We fill the open part of the seal with a silicone grease. We do this to both seals. We also put a small amount on the lip area prior to installation. We have a special sleeve with a taper which we insert over the threaded area of the water pump shaft. This is to protect the seal lip as we ease it over the shaft. The inner seal is installed with the closed side facing you, the open side going over the shaft. We also have to be careful with this earlier model engine. The bearing, as we previously pointed out, is not retained by a circlip. If we knock this seal in too far, we will dislodge that bearing. We have to initially check the depth of the bearing, recording the depth. We would measure the width of the seal, and we can then see how far we need to install the seal. We need a drift or a socket. There is some special tools available, but these will suffice. Neatly fitting just on the outside diameter of the seal. We're gently tapping it into the bore. Checking a measurement as we go. We want a quantity of the grease to be retained between the two seals. We put a liberal amount around the closed area of the seal. We have a distance ring that is to be inserted between the two seals, and this closed end, so this open end, must be installed so that it does not restrict the hole that we previously showed you. Remember, we're putting them back to back. We've installed our distance ring. We have our grease reservoir here. We now fit the shim. Our rubber washer. At this point, if the seals are installed correctly, the rubber washer should be in line with the counter bore. We now fit the support plate. We have a special tool available. Once again, a socket or something of that nature, or a sleeve that fits the outside of it reasonably. The support plate is just knocked in until it bottoms just slightly under flush. We're now up to fitting the water pump impeller. We just give the end of the shaft, the thread area, a clean with our primer T, because we will be putting some Loctite on that shaft to assist retain the nut. We have small flat washer installed first. We have a serrated washer which will bite into the back of the nylon impeller. The shaft has a flat, and likewise the washer and the impeller have that flat on for location and drive. Then we install the impeller, flat washer and our nylock nut. Prior to putting the nut on, we are using also our Loctite 680. A couple of drops on the shaft, on the thread. Install our nut. To enable us to be able to torque this, we need our fixation rod. We'll now tighten up our impeller nut, 7 Newton meters or 60 inch-pounds. After fitting the water pump impeller, we will now be looking at reattaching the water pump impeller housing. We have a new gasket fitted. We must assure ourselves here that the screws that hold this housing on have to be located with a Loctite. We're using a 222. The reason being, some of these screw locations are not blind holes and go into the crankcase area and the water gallery area. It's most important that we do put our 222 Loctite on these areas. The cap screws are nipped up and then torqued to a final tension of 8 Newton meters or 60 inch-pounds. After servicing our stator plate electrical assembly points condenser checks, we'll be installing the stator plate and setting the timing. We'll be feeding the loom through our access hole. We install the stator plate assembly in its location, making sure that the wires are not caught underneath. We have our 2 retaining Allen head screws. These will later be fixed with Loctite, but whilst we're doing the timing, they are just used as they are. We initially locate the stator plate with the slot about central with the screw. We now have to install the magneto hub. Unlike the 503, which has the eccentric on the crankshaft which actuates onto the contact breakers, the 532 has the eccentric located on a boss on the flywheel hub. Therefore, we need to install this on the engine before we can attempt to adjust the timing and or alter the point gaps. The magneto hub is located onto the crankshaft via a keyway. We will just temporarily install our hub locking nut to enable us to be able to use this to turn the engine over whilst we are doing the timing. We just require to nip up the nut We only need to be operating it backwards and forwards whilst we do the timing. At this point in time, we install the dial indicator. We have our tone timer, which is just purely a buzz box. One lead we place to earth, the other we would locate in one of the kill switch spade connections. We've set the dial indicator up so that we're reading top dead center. We have 0. We have our dial tone timer. We wind it firstly a little bit over center in the direction of rotation. We put our tone timer on. We are winding it back. We've gone 100 millimeters, and around the 200 millimeter mark we have a difference in the tone on the timer. We are looking for 1.96 millimeter. As we wind it back, we find a difference in the tone around about the 1.96 to 2 millimeter, which would just do us nicely. We will now check the point gap and see if it corresponds with the specifications in the manual. We'll put the tone timer off. We'll bring the engine back to top dead center, because this is the area that we actually check the point gap. We have the correct amount of tension on the gauge. We have the correct amount of firing before top dead center. We have our 1.96 within 0.05 millimeters, which will do us. That's within the specification. We'll now just make sure that we have the point screw, locking screw, fastened correctly. Alright, we've done the magneto cylinder. We have the timing, we've set the contact points. We would now do the PTO cylinder. The procedure is exactly the same as what we've just demonstrated, and then we'll remove the magneto hub and lock off the stator bolts. For reference, we have already shown we've adjusted the timing to the 1.96 millimeters, which is applicable for this 532 engine. However, in adjusting the points to attain this specification, I would just like to point out that by having a narrow gap on the contact points, we would be looking at a retarded timing. If we just go back to top dead center, we're coming back before top dead center, our 1 millimeter and our 2 millimeters. Our timing has been 1.96, and we have 15 thou gap in our contact breaker. If, for instance, we had 12 thou gap, we may be having our tone timer sounding off around this area, the 1.6, 1.7 millimeter, which would be too far retarded for this timing. If, however, we had our contact point gap at, say, 16 or 17 thou, we'd be looking at advanced timing, and we'd be up around the 2.4 or 2.3 millimeter. We would then have to readjust the contact breaker back to get our optimum setting of the 1.96. If, for instance, it was a 503 air-cooled engine, the factory allow us a tolerance of 1.83 millimeters to 2.33 millimeters. Our optimum for the twin carby is around the 2.07 to 2.10 millimeter. However, in this instance with the water-cooled 532, we are looking at the 1.96, and that is where we leave our adjustment. Now we've just removed the dial indicator from the mag cylinder to the PTO cylinder. We also have to disconnect our tone timer spade connection from the one cylinder to the other cylinder. Having done our timing, we now need to remove the hub so that we can correctly fix the stator plate. We reinsert our fixation rod, locking the crankshaft, removing our hub nut, we now remove our hub. If any difficulty is encountered, go back and pull the plate and puller assembly that we have shown in the previous procedure. We would remove our fixation rod. We now want to make sure we have got one screw locked up, and we'll be looking to take the other screw out so that we can apply the Loctite. After removing the screw, we are cleaning and priming with some Loctite grade T primer. We would allow the primer to dry for a couple of minutes. Then we will be applying our 222 super screw lock. We reinstall the screw. We would now at this point tension the screw to the required torque, locking it up and then moving on to the other screw. We remove the other screw and do exactly the same procedure as we've just carried out. We've now finished the assembly of the stator plate. We need to permanently fix the magneto hub. This is one of the only items that does have Loctite on a tapered surface. We've previously cleaned it in our cleanup following the disassembly. We only need to apply our 222, and I must emphasize that it only has to be the low screw lock 222, nothing higher in that number. We just put a small amount around the taper area. The crankshaft has a keyway, the hub has a keyway slot. We mate the two and locate it on the shaft. We also apply some 222 to the thread area. Install our spring washer and our lock nut. This is then torqued up using the appropriate fixation tool and torqued to the specification in the manual. Our gearbox has been overhauled, serviced. We will now be putting the adapter plate and the gearbox on this engine. There are two different types. The earlier type of engine has this separate type adapter plate. The later engine uses the one-piece gear housing. Prior to fitting this, we must put our drive gear on the crankshaft. In disassembly and cleaning, we have already cleaned and pre-treated these with our Loctite primer, even though I must emphasize we do not use at all any Loctite on this taper area. We are merely using the primer as a cleaning medium only. We install the gear on the shaft. We lock our crankshaft with our fixation rod. Rotax will allow us to use this rod even though we are up the other end of the crankshaft and we are torquing this gear. The tension is not sufficient to create any problems with the crankshaft. We are giving our fixation bolt a priming and a cleaning with our primer. We will use on this bolt, however, our Loctite 222. We locate the bolt in the end of the shaft. We tension the gear to 60 Newton meters. We're now ready to install our adapter. We have 2 O-rings located on this adapter. We apply a small amount of our grease to the groove just to assist in locating and holding this O-ring whilst we are placing this adapter on. The other O-ring is located around the flange. We don't need to put any grease or lubricant around this O-ring. We now have to prepare the fixation bolts for the adapter, which requires 2 different areas and 2 different types of Loctite application. We use the 680, which is a high strength and green in colour, and we need to apply this on the underside of the head area. We do this to all of the 4 bolts. We now apply our 222 thread lock to the thread areas. We also put a small amount on the outside area of the boss, which will mate up to the crankcase mounting. The adapter will fit either way, allowing the gearbox to either be up adjacent to the cylinders or down adjacent to the crankcase. So we make sure that we have the adapter fitted to what suits our application. We locate it on the boss, install our retaining bolts, we now need to adjust these cap screws 55 to 60 Newton meters. After mounting our adapter plate, we're now ready to mount our gearbox. We have our O-ring installed. There is no gasket. However, we do apply a small amount of our 680 Loctite around the outside area and a small bead around the inside area. The gearbox is located over the studs, shaft rotated. It's fixed on by the spring washers and nuts. no Loctite, and they are just tensioned to 22 Newton meters. That completes our gearbox installation. We'll now move on to a further assembly.